Okay. So y'all did pretty well. And I'm not surprised because y'all been doing pretty well on everything. Let's just see how this works. Okay, to sketch the graph of this thing, you got p of x. Let's say it's x minus 4 times x plus 9 log b squared. And well, okay, pretty clear that your zeros are x equals -4 and x equals 4 and x equals -9. Anybody totally understand that? Because those are the values that make this thing 0. And those are the x-intercepts. Okay. And one thing we always do in front of graph something is find the intercepts. Gives us a good start. Then y-intercept happens when x equals 0. So y would equal 0 minus 4 times 0 plus 9 quantity squared. That's negative 364. If I did my arithmetic right. Okay. And that's not right. 324. 4 times 9 in my head. Instead of 81 times 4. Okay. So if I did my arithmetic right, that's how. Okay, then long run behavior. And now you systematically, you see a polynomial, you find the intercepts, the zeros in the y-intercept. Okay. And you check the long run behavior, and then you make it fit. The long run. Okay. Now, what does y approach? When on 3, I want everybody to give me this for plus and this for minus. Okay. So, everybody ready? Does it approach plus infinity or does it approach minus infinity? Okay, 1, 2, 3, tell me. Okay, because x goes infinity, y approaches infinity. Yep. Because it means x is a huge positive number. If x is a huge positive number, you almost might as well just be multiplying x by x squared, right? The -4 and the 9 aren't going to make much difference if x is 12 billion. Okay. So it's like 12 billion times 12 billion squared. Well, it's all positive. So there we have it. Okay. Oh, same thing. Next goes to negative infinity on 3. Ready? 1, 2, 3. Okay, didn't see everybody, but it's going to be negative. Okay. Because if x is a big negative number, you got a negative here, and you're squaring a negative here. Of course, you square a negative, this is going to be positive, so this is the only one that really matters. And it's negative, so you're going to get negative infinity. Also, the infinities for y are much bigger than the infinities for x. Because if you multiply a huge number by a huge number, we talked about it last time, grains of sand and so forth. Okay, you got a really huge number. Okay, then we start sketching our graph. Now we could have started at any point since you had the zeros. We could have indicated them, but zeros are at 4 and -9. Y-intercept is at -344. Now we'll put that down here. And what else? As x goes to infinity, y goes to infinity. I'm going to draw an arrow this way and an arrow this way. Okay. Now I've got to hit this point, and this point, start low, end up high. If you started your graph here and ended your graph here and got this point, give you half credit on the test. But I want to see the behavior as I approach infinity. So we got to start down here. Now, if we start down here and go up through here, we don't have a way to get back to this point, do we? Because we can't go through the x-axis except the thing is 0, and it's not 0 at any other value other than these two. And that's our hint that we just don't go through 0 here and come back down here and here, because then we'd have a 0 here and there isn't one. We start down here, we come on up. Here, as in a parabola. Then we come back down here. And then up here. And there, incidentally, it's not very well drawn. It really probably doesn't look like that, but there's no reason that this should be your low point. Nothing at all makes that the low point of your graph. So you kind of decide, well, 9's further on this side than 4 is, and this side 9 is squared. So your low point is probably going to be closer to x equals -9 than it is to x equals 4. You don't really have to do that. If you put your low point here, I'll just say it's not really there. But in calculus, there's a real easy way to determine what your low point is. It's easy. One of the easier things you do in calculus. So I'll leave that until we take calculus. Okay. Pretty much everybody had a graph that looks not like that. If it doesn't, if you start it up here and stuff, you want to think. Thing you want to understand, this is 0 multiplicity 2. The x plus 9 squared. And what is it about this? Well, it's a square. And as I said last time, it acts a lot like a parabola close to this point. And the reason for that is x minus 4 doesn't change real significantly as you move past this point. Okay. But the squared x plus 9 does. So it's almost like you have a vertically stretched parabola at this point. Worth understanding that. You got the procedure down, whether you understand what I just said or not, you're probably going to be in good shape. Then the equation for this graph. So let's just redraw. I think I could draw a straighter y-axis. Just not. So let's say this is -11, and this is 14, and this is 23. So we have a graph that does the same thing. And it doesn't wobble like that for you. It's nice and smooth. It's not very well drawn. That one was pretty well drawn. Okay, so we see we have zeros. -11 and 14. 0 at -11. Has a multiplicity of 2. 0 at 14 has a multiplicity of 1. Because this acts like a parabola here, it acts like a straight line over here. So P of X equals some number that I'll call A times X minus 14 times X plus 11 squared. Because the zero multiplicity of X equals negative 11 occurs if you do X plus, if you have X plus 1 squared as a factor, okay? And zero multiplicity of 1 occurs at X equals 14 if you have a linear term, X minus 14. There's an A out in front, and you don't know what A is yet. The hint for doing A is you have a point. It doesn't have to be the y-intercept. It could be any point on the graph. If you have any point on the graph, you can plug its X and Y coordinates in here. And this is kind of a good idea to write Y equals P of X and know what Y is what we're talking about when we talk about Y. So if you have any point on the graph, when you get it down to this expression, if you plug in for X and plug in for Y, you only have one thing unknown, and it's easy to solve. It's a very easy step. You just have to know to do it. You have to know that this is the form. So y-intercept is at 0, 23. So 0 equals A times 23 minus 14 times 23 plus 11 quantity squared. There'll be something wrong there. I don't know where this is going. I know that's not going to work. 23 equals A times 0 minus 14 times 0 plus 11 quantity squared. Well, you multiply that up. 11 squared is 121. Let's see. 14 times 120 is 1680. So it ought to be negative 1691. I have about a 30% chance of being right on that, so you check me. Okay. So A is negative 23 over 1691. Really bad looking 6. There it is. So P of X equals negative 23 over 1691 times X minus 14 times X plus 11 quantity split. And your solution would have looked very similar to that, but you'd have different numbers. If you got that much down, you're doing really well. Okay, now a straightforward example of long division. We're going to divide X minus 5 into X squared into X squared minus 6X plus 5. What I get up here is going to be the quotient, and the quotient multiplied by the divisor, this is the divisor, should equal the expression we're dividing into, called the dividend. Okay. So what we're going to get up here times this is better equal this, otherwise we haven't divided it, right? Because division means you're trying to find the number that multiplies this to give you this. Not something you just punch into a calculator. There's an idea behind it. Okay. And you can't punch this into your calculator. Put it into a computer algebra system. Can't punch it into your calculator. Okay. You got a good graphic calculator, it's some algebra change, always probably can. Still, you need to understand the process. So, process basically, what would I multiply by x to get x squared? Because whatever goes up here, it's going to have to multiply this, right? In such a way that I'm going to get an x squared. Well, what do I multiply by x to get x squared? Well, I multiply x by x to get x squared, right? Okay. So if I've got an x up here, then when it's multiplied by this, I'm going to have an x squared minus 5x. Okay. So this times this already gives me x squared minus 5x. So I'm going to take this away from what I've got here. You see what I've got left. When I do this, if I take this away from this, I'm going to have to subtract it, which means I'm going to have to subtract this from the x squared. I'm going to have to subtract negative 5 from negative 6x. That's the same as adding 5x to 6x. Okay, so I put little tiny minus and plus signs there before I do anything else, so I don't screw it up, because it's real easy to screw that up. You see this with a minus here, you want to do minus 11x. Okay, and you have to overrule that because that's not what's going on. So it's a good idea to write these symbols here. And this gives me an x plus 5. Okay. Now, I have to have something here. When I multiply by x, I get x. What would that be? Oh, that's a 1. So 1 times x gives me x. And then I'm going to get 1 times, of course, the whole x minus 5. Okay. Then I got to subtract that. So I got to subtract the x and add the 5. And it gives me 10. Well, that's my remainder. There's nothing I can multiply by x minus 5 to make up that 10. That's what's left over. Well, I could write that with remainder 10, but I'm going to write that as plus and divided by x minus 5. Okay. Because that's the way you do long division with numbers. Whatever you got left over here, you put it over this. You get a fractional remainder. Well, you get the remainder, and then it gives you a fraction on your solution. Now let's check this. Well, you check it. If I got lucky and did this right, when you multiply this out, you should get this. Okay. Now, I've told you that when you have a denominator in an equation, you automatically want to multiply both sides by that denominator, right? But in this case, this denominator is going to disappear when I multiply this, because I'm already multiplying by this denominator. Okay, so I don't need to do that step. If I do it's going to complicate the equation. Okay, I'm already multiplying this expression by the denominator, so I don't have to do it again. So multiply this out and see what you get. Don't skip any steps. Give you enough time to do it. Okay, now if you did this right, you caught me in a mistake. I tended to make a mistake just so I could illustrate the pitfalls. Okay, I really made a mistake. My mistake was negative 6x plus 5x is negative x, right? Okay. And then that's going to come out a little bit differently. That's why we checked. Okay. So I wasn't being all that careful because I knew I might make a mistake, and if I did, it's okay. Okay, so here's what comes out. Now, first of all, some of you have a little trouble doing this. Okay, x minus 5 times this times this. Okay, I'm going to write that out as x minus 5 times x plus x minus 5 times 1 plus x minus 5 times 10 over x minus 5 equals this right hand side that I don't have room to write. Okay. Not doing anything magical. I'm being very careful, doing every step. My distributive law says I can multiply this by each term. Okay. Now, if I multiply x by all this and then multiply minus 5 by all this, it's going to be a little bit confusing. It can work out, but it gets more complicated. The reason I choose to multiply x minus 5 by all this is I'm going to get to multiply x minus 5 by 10 over x minus 5. That's just going to leave me 10. So if I multiply this out, now I get x squared minus 5x plus x minus 5 plus x minus 5 times 10 over x minus 5. Well, I could write that as x minus 5 over 1 times 10 over x minus 5. I see that the x minus 5 could go over the x minus 5, the 10 could go over the 1. X minus 5 divided by x minus 5 is 1. So I've got 1 times 10 over 1, and that's 10. I can write my right hand side. Okay. Then collect my terms. I've got x squared, and I've got minus 5x plus x. That gives me negative 4x, and it doesn't match at that point. I'm supposed to get a negative 6x. I do get a plus 5. Minus 5 plus 10 is 5. Is not equal because we have a negative 4 here and a negative 6 here. This causes me to go back and look at what I've done. What have I done? Well, I already pointed out. Negative 6 and 5 is negative 1. Okay. So now I can correct this. Okay, this should be negative x. And I have plus 4. Okay. And when I multiply, well, at this point,
Oh, you're right. I'm feeling better. Fine.
divide x into negative x. So what do I multiply by x to get negative x? It's clearly negative 1. I multiply by negative 1, I get negative x plus 5, which gives me a remainder of 0. So I could write now 0 over x minus 5 But there's really no point in writing 0 over x minus 5, that's 0. And I don't even have to write it down. And I don't usually write down the 0 there, I just notice that this matches this, so when I subtract, it all works out and I put a double underline there. Pretty much the standard way of doing it. Now, get more complicated, and if I check this, okay, if I change this 1 here to -1, then this becomes a -1. And of course, I don't have the 10 over x minus 5 anymore. I'm just going to leave that positive. There was original. Dividend, and it's wrong. Okay, now check. No, I'm just going to multiply this by this and see that it equals this, and that's really easy. I hardly even have to write it out if you're used to doing this. But writing it out, here it is, x minus 5 times x minus 1, distributable, and all that stuff gives you x squared minus 5x minus x plus 5, which is x squared minus 6x plus 5, equal x squared minus 6x plus 5, and it checks. Now this illustrates something. A little hard to read. We know that x minus 5, x squared minus 6x plus 5 equals x minus 5 times whatever the quotient is. Okay, of course, we know what the quotient is. And just make sure we know. We have a divisor. We have the quotient. And this thing is called the dividend. Okay. If whatever the quotient comes out, the divisor times the quotient has to equal the dividend. If it had been with a 10 over x minus 5 here, then this would have worked out. Okay, the divisor times the dividend would equal the quotient. And many times you have this. Well, in this case, the quotient isn't just a simple polynomial. Okay. But if if these are all polynomial, if these are both polynomials, and the quotient comes out without a remainder, then quotient is a polynomial. In other words, you're going to get a polynomial up here unless it doesn't work out at this step. And it follows then that x minus 5 is a factor of this. Now that becomes important if you're trying to factor a trinomial. I mean, a cubic equation or greater. And you can always factor a quadratic equation if it factors over real numbers. You can factor. Okay. That always factors over complex numbers. We'll talk about that in a little while, but you have the quadratic formula that allows you to find the zeros. And then it's x minus this 0 times x minus that 0, or whatever. If you have a cubic polynomial, it gets way trickier. So I want to know is x equals 2 0 this polynomial? Well, you can plug x equals 2 in and see what it is. Okay. X minus 2 is 0 of x squared minus 7x plus 10. Well, yeah, you plug it in, you get 4 minus 14 plus 10. Gives you 0. So when you divide this, you're going to get a polynomial as the quotient. Now up here, x minus 1 is a polynomial. Yeah, it's a linear function, but you know, it is a polynomial because a polynomial just consists of powers, multiples of powers, positive power, non-negative powers, non-negative integer powers of x. Okay. And you pretty much know what a polynomial is. We'll divide that out. Just go ahead and do that division for practice. And then we're going to do one that shows you how we could use this idea to factor a cubic equation. Okay, now the task was to divide this into this. And people are many people are a little shaky on the long division process. You're going to have to practice it, and open math will correct you in the way you all through work habits and stuff, I don't think you're gonna have any trouble with it. But let's see how this works out. Okay, you got x minus 2. I won't say you won't have any trouble, but you get it sorted out. I don't think it's too hard. Okay, we're dividing this into this. Now, why are we doing that? Because we've already found out that x equals 2 is a 0 of this polynomial. Now we can factor this polynomial, and let me just digress for a second before we get into this. I'm not going to teach you how to factor trinomials. I'm not going to do that in class. Okay. If you don't remember how to factor trinomials, look it up. It's something you did in Algebra 2. And it's something that I've always found people, it's the one thing in Algebra 2 that people usually come out of school pretty good at, okay? And with the COVID stuff and everything, maybe not, but we really can't take class time to do trinomials, okay? Factoring trinomials. Now, we did some of it in the MDE course, MDE 61, okay? And those videos are there on your Canvas site. So go back a couple of days, okay? Go back to as late last week and early this week. And if you want to see what we did, because it's not particularly hard, there's a system, and I think we went over the system on Tuesday, all right? Some of them are a little harder to factor than others. So Tuesday's video, when we get into factoring trinomials, will probably be a valuable reminder for you, but you can find it. I mean, you look up factoring trinomials and you get 48 trillion hits. Well, not that many, but you get, all kinds of stuff. Khan Academy does. Everybody does it. And you can also go to the mark. Okay, but then I need to get trinomials. Okay, so this trinomial factors x minus 2 times x minus 5. Check it out. Minus 2 times minus 5 gives you 10. Minus 2 plus minus 5 gives you negative 7. You're done. Okay. If you don't remember that, review it. I'm sure you've had it. Okay. So anyway, we divide this. Now again, what do we put here? What we put here is what multiplies this to give us this. That's going to be x. X times x is x squared. X times negative 2 is negative 2x. We have to subtract this from this. Otherwise, we'd get a 2. If we added these, we'd have 2x squared. Okay, we've already got all the x squareds we want if we multiply x by x. Okay. So we've got to subtract this, which means we're going to change these signs, but we're not really going to change the signs. We're just going to write a little minus up here and a little plus here to remind us what we're really going to do. Now, negative 7x plus 2x is negative 5x. Yeah, bring down the plus 10 because I know that when I write whatever I need here, so when I multiply this by x, I get negative 5x. I'm also going to get something on the 2 that's going to line up with that 10. Okay. Well, obviously, if I'm going to multiply x by something to get negative 5x, I better multiply it by negative 5. That's going to give me negative 5x. Negative 5 times negative 2 plus 10. Look at that. When I subtract this from this, they match. So when I do the subtraction, I get nothing. I get 0. Okay, so if we didn't already know it, I've discovered it just by knowing that negative 2, or the 2 is a 0. I can find my other 0. Okay. Now I'm going to have to do this kind of fast. I'm not going to let you do it. So I know you're disappointed. You're not going to have time. Let's take let's see. I didn't want to do that. I put 15x. Okay, we get this polynomial. By trying some obvious substitutions, I could plug in x equals 1, or I could plug in x equals -1. I could try 2, I could try -2. Okay, even 3 or -3. And there are other things I could try. So just by trial and error, I might be able to find a zero of this function. Well, let's start with 1 because it's really easy to plug in 1. Well, I get 1 here, I get -6 here, gives me -5. And I get 1 here, added to -5 gives me 10, let's subtract 10, I get 0. Okay, so by inspection, x minus 1 is a 0 of my polynomial. So x minus 1 should divide a polynomial. To get a polynomial function. That is, it should divide it without remainder. If you got a remainder, you no longer have a polynomial. You've got something with a denominator that makes it not a polynomial. Okay, well, I'm going to get into all the detail of that. What I'm going to do is, let's see if that works. X minus 1 into x cubed minus 6x squared plus 15x minus m. Now, I don't remember if I've eliminated synthetic division completely from the open math. There's a process of synthetic division where you can make this a little quicker, but I don't like to use it because people don't understand how it works. They can work it, they can do it. It's real easy. You just write down some numbers and do some stuff that's a lot like what you do with long division. Okay, I don't like to bypass long division for synthetic division. Okay, but it's a handy tool if you understand long division and how it's related. Anyhow, you're going to get x squared because what do I multiply up here by x to get x cubed? It's got to be x squared. I get x cubed because then I've also got to multiply it by the -1. Then be careful to mark what I'm really going to do. I'm going to add x squared to -6x, which gives me -5x squared. We're going to bring down the 15x to match up with 2x minus 1. Then what do I multiply by x minus 1 to get -5x squared? Well, obviously, -5. So when I multiply -5 by x minus 1, I get -5x squared, which is what I wanted to do. -5 times 1 is +6. -5x squared. Okay. Then I do a plus here and a minus here. Which gives me 9x. I'm going to have a -10. You know, I wanted to write down the -9 there. That's giving me a -5, 15. Still. I mean, my. Positive not up to 16, my negatives are up to something's haywire here. I don't know what it is. Okay. So I add 9. And multiply it. And I get 9x minus 9. Either I'm losing my mind or I just made an error. That 6 there must have caught my eye. Be 5x. For some reason I wrote down a 6x here, but -5x times -1 is plus 5x, right? Yeah, I think I caught that 6x squared or something. Shouldn't have done that, but I did. At least I checked. Okay. Well, that tells you then. That this polynomial reduces to this. Okay. I also can check very quickly to see that this polynomial doesn't have any zeros. I do that just by plugging into the discriminant, the square root of b squared minus 4ac. And the minus 4ac is going to be really big, giving you a negative under the radical, telling you that this can't be factored over the real numbers. Okay. Maybe store this away. Any polynomial of any size can be factored down into product of linear factors like x minus 1, that's like a linear function, and quadratic factors that don't reduce. You never need a cubic factor. You can always get it down. I mean, it always is product of linear and irreducible quadratic factors. That's a big deal. Fundamental theorem of algebra, in fact, and we'll talk about it next time. Get the long division down, learn what it tells you about long division, but I've given you a little bit of information about why we do it and where it's heading. You won't have to do that until Monday, but I want to give you a head start.